Hey guys, it's me Precious Manchti Mantara, and today we will talk about the continental drift theory. I'm certain you've encountered a world map before, most likely during your early years in school. You notice that the continents, which account for approximately 29% of the planet, fit together as if they were puzzle pieces upon closer inspection. This is especially true when examining specific regions, such as the eastern coast of South America and the west coast of Africa. Although this has been a well-known fact for centuries, there have been a few courageous scientists throughout history who believed there was more to it than mere coincidence. So today, allow me to introduce you to one of these esteemed scientists with certainty. This is Alfred Wegener. He was a brilliant mind of his time, deeply involved in the study of atmospheric science as a weather expert. His fascination with maps led him to discover a peculiar phenomenon that captured his imagination and became the focus of his life's work. He also spent countless hours studying this phenomenon and eventually developed a revolutionary theory that challenged the established scientific beliefs of his time. Wegener also proposed his continental drift hypothesis or continental drift theory. According to his theory, the continents were once joined together, forming a single massive landmass which then separated and drifted apart over time. Wegener firmly believed that the continents were not motionless but were in constant motion, moving and shifting to their current positions. With great confidence, Wegener bestowed upon the ancient supercontinent and named Pangaea or Pangaea, derived from the Greek term meaning all Earth or entire Earth. In his meticulous calculations, he proposed that Pangaea existed approximately 300 million years ago, and his accompanying illustration depicts a striking image of the present-day land masses of North America, Africa, South America, Antarctica, India, and other continents, which have since drifted apart from their original configuration. Wegener also hypothesized that the supercontinent Pangaea, made up of a northern group of continents known as Laurasia and a southern group of continents known as Gondwana, broke up about 200 to 250 million years ago, and that the individual continents eventually drifted to their present positions. So before ito nagkaroon ng and continents is nag-start pa jud siya sa duha ka continents. So Wegener divided it into two continents, which is the Laurasia, the northern group of continents, and the Gondwana, the southern group of continents. Despite facing skepticism from his peers, Wegener remained steadfast in his belief and tirelessly supplied evidence to bolster his theory, demonstrating an unwavering commitment to scientific truth. So during his time, Wegener was very curious why ang continents daw is just like a jigsaw puzzle or a puzzle pieces. Like what you observe nga ang South America and Africa, if imo siyang iduol is more siya kanang fit jud siya. Fit jud silang duha. But then on, during his time, continental drift theory was ridiculed by the people. That's the reason why nga si Wegener nag-provide siya og tulo ka klase nga evidences. First, we have the matching features. Second, we have the feet of the continents. And third is the paleoclimates.
So, good day everyone. This is Sherwin B. Tilos. So, good day everyone. So, today let's talk about evidences of a continental drift theory. So, there are evidences which can prove that continental drift really exists. So, we have matching features. Plants and animal fossils found on separate continents from linked patterns if the continents are reassembled. So, natay ginatawag nga Pangaea, which is the continents are being separated. Bali, as shown in the picture, South America, Africa, India, Antarctica, and Australia are separated. So, kung isumpay na nimo, na ay species or fossil sa species na imong makita sa isa ka country na same sa laing country. For example, nakakita ka og fossil sa snail um, sa South America. Unya nakakita sad ka og same kaayo nga fossil sa snail sa South Africa. So, mao na siya ang pamatuod nga continental drift really exists. So, kanang brown dira, mao na ang fossil sa species which is natunga siya. Ang katunga sa iyang fossil is nagpabilin ug ang katunga naadto sa laing country. So, these are the evidence of continental drift. So, for example, no, large nga hayop tapos na-decompose. So, ang iyang fossil is nagpabilin sa yuta. Tapos, when continental drift happened, natunga to siya ug ang katunga sa iyang fossil na adto sa laing country niya ang isa is nagpabilin diri. So, mao na siya, evidence of continental drift. So, mountain ranges. Highlands in South Africa and Argentina are also called is the South America, and mountains in Western Europe and Eastern Canada can be aligned to form continuous mountain belts when Pangaea is reassembled. So, makakita tag mountain, for example, sa Mount Apo. So, na siya'y mga parts, bali, na siya'y side, na siya'y pika side, na po siya'y lawas. So, when continental drift happened, ang lawas ana niya is magkatibulaag or magkahiwalay-hiwalay. So, bali, maadto siya dito sa South Africa, sa America, sa Eastern Canada. So, mao na siya makitaan sa mapa nga nagbulag na siya. So, kung imuha na siyang isumpay ang mga parte, mahimo gihapon na siyang mountain. So, mao na siya, isag gyapon na siya sa evidence nga ang continental drift really exist. Okay. Similar unusual sequences of rocks are formed in Brazil and West Africa and elsewhere throughout the continents of the southern hemisphere. Later, researchers were able to identify 2 billion years old rocks in Gabon, West Africa, that match up with rocks of the same age on the other side of the Atlantic Ocean in northeast Brazil. So, mao ni siya ang ginatawag pod nga evidence sa continental drift. Kay ngano, our researchers found a rocks which is present sa Brazil and present pun siya sa West Africa nga perti gyud kakapareha. So, bali sumpay gyud ito siya nga continent, and then pagbulag nila ang some fossil sa isa ka rock is naadto dito nga continent ug ang isa nagpabilin sad sa kana nga continent. So, this mao jud ni siya ang nagpamatuod nga ang continental drift existed. Okay. So, we have the feet of the continents. So, we can see the South America and the Africa. Looking back at the picture of the matching features, we can see the Cyanogathus, Mosasaurus, Listosaurus, and the Glossopteris. So, this Mosasaurus is makita lang natin siya sa mga places or sa fresh water. So, it made the scientists wonder nganong ang fossil sa Mosasaurus is makita sa South America and sa Africa, knowing nga ang Africa ug ang South America is naay distance or lagyo silang duha. So, ang ilang pagitan is mga freshwater. So, ang ilang theory ani nga ang South America ug ang Africa is really connected, and it is very impossible pod nga ang Mosasaurus is mag-travel through salt water from South America to Africa, and at the same time very impossible pod nga mo-travel ang Mosasaurus from Africa to South America. So, South America and Africa in their theory is really connected.
Hello everyone, I'm Ivy Garcia, and now let's tackle about the paleoclimates, ancient climates. Wegener also documented that identical glacial deposits formed about 300 million years ago in India, Australia, South America, and Southern Africa all exhibit evidence of thick ice sheets similar to those found in Antarctica today. Wegener pointed to several lines of evidences to support his paleoclimates, and it includes the glacial features. So ano nga ba ang glacial features? Glacial features, ito yung landforms and geological structures created or influenced by the movements and action of glaciers. Glaciers are large masses of ice and snow that flow slowly downhill under the influence of gravity. As they move, they erode, transport, and deposit sediments, shaping the landscape in distinct ways. And also, these glacial features provide valuable insight into the Earth's past climate and the dynamic processes that have shaped its landscape. The study of these features is important for understanding the history of glaciation and its influence on geological formation. So, yun yung glacial features. Widespread glaciation could be best explained if certain continents were located close to the South Pole. That's why Wegener noted that glacial deposits and striations found in areas like South America, Africa, India, and Antarctica indicates that these regions had once been located closer to the South Pole. This evidence suggested that these continents had experienced much colder climates in the past, which was consistent with the idea of them being part of a southern supercontinent. At napansin nyo naman sa pictures na yung lugar ay nagkakahiwa-hiwalay. Wegeners also argued that these features could only be explained if these continents had once been joined together and had drifted apart.